someone.
Hello and welcome to today's episode of Rawkode Live. I'm your host, Rawkode. Today we are taking a look at multi-tenancy on Kubernetes through a project called vcluster. Now before we get started on that, there's just a little bit of housekeeping. First and foremost, please subscribe to the channel, like the video and click the bell. This will keep you up to date with all new episodes of Rawkode Live. It will also encourage the YouTube algorithm to share this content with the broader cloud native ecosystem. We also have a Discord channel available at rawkode.chat. If you want to request new technologies to appear on the show or talk about any existing or previous episodes, that is the best place to do so. Feel free to jump in there and join the conversation. All right, now for today, for vCluster, I am joined by two fantastic guests, Rich and Lukas. Hi there both, how are you?
Hey, really good.
Awesome.
Hey, thanks for having us.
It's my pleasure. I'm really excited to take a look at vCluster today, kick the tires on it, see what it's capable of, and share that with everyone that is watching. Can we just take a few moments, please? If you both introduce yourselves, tell us a little bit about you, and then we'll talk about vCluster. And I'll throw it to you first, Rich.
Yeah, so I'm a senior developer advocate at Loft Labs. I've been with the company for about 3 months now, and I'm really enjoying it. I've been in DevRel for a few years now, but have a long history of different kinds of ops roles before that, sysadmin roles, SRE, all kinds of stuff over the years. So, yeah.
And Lukas?
Yeah, hi, I'm Lukas, CEO at Loft Labs. I brought Rich in a couple months ago and super excited to be working with him. And we launched vCluster a couple of weeks ago, and I'm trying to hop on as many streams and calls as possible to tell people more about what we're up to right now.
Awesome, thank you. And thank you, Noel, for telling us my audio was on during that video. After I assure everyone that that is not the case, I guess I made a mistake. Sorry about that.
Oh, I guess I missed an opportunity to plug my thing, which is that I also do a podcast about Kubernetes called KubeCon. So if you just search in your podcast player for that, you should find it.
Don't you worry. I was going to mention KubeCon anyway. I'm a big fan. It's a great podcast, and I encourage everyone to check it out. All right. Let's start then with a little TLDR on what vCluster is. Which one of you would like to tackle that?
I'll start off. So vCluster is basically a solution to the pain of Kubernetes multi-tenancy. So if you have used Kubernetes for a while, you have probably run into the situation where you're using namespace-based isolation, and there are things you just can't do, right? You can't manage cluster-wide resources as a user in a namespace. And so this is actually something that was built into our commercial product, Loft, and then we kind of pulled it out and open sourced it recently. Lukas, is there more you want to share?
Yeah, I think, that was a great intro. I think you said pretty much everything except, vCluster is more than just multi-tenancy. It's really just an efficient way to also create self-service for Kubernetes clusters. Because, as soon as you have access just to a namespace, you can basically now spin up your own Kubernetes clusters. I mean, they are virtual. They don't have their own, VMs and nodes. But with this restricted access, you can essentially make yourself cluster admin for, this virtual cluster, which is, something that people often forget when they think about virtual cluster. And I think it's actually one of the most exciting parts.
Nice. And I mean, in terms of the technical end of it, you've got a namespace on the host cluster, and inside of it, there's a K3s API server. And that is basically your Kubernetes API, within your vCluster. So it looks to the user like it's a full-blown Kubernetes cluster.
So what are some of the more common use cases for this? What do you see people adopting vCluster to do beyond just multi-tenancy? Is there like a broader picture there?
I think
Yeah, I
that
think to get a little bit into the details. Oh, sorry, Rich, go ahead.
no, go ahead. I was just going to say, I think, there are a number of use cases, but to me, probably the most interesting one is, Lukas mentioned self-service, and I think, this is great for dev environments. If you don't want to have, different clusters spun up for different teams, you want people to be able to do self-service and just get on with their work as they need to. I think that that's one of the better use cases. CI/CD is potentially another use case, so instead of using something like kind and having to provision something, every time you run a set of tests, you basically are just leveraging this cluster that's already there and just creating a namespace on it, which I think is likely a lot faster.
Yeah, definitely. I think, just you mentioning those use cases there, I'm thinking about how, CI/CD is one of those things that when you run it in your cluster, it normally needs quite a lot of privilege. Like it does some magic stuff. It's either building container images, it needs access to the host paths, or it needs, service accounts with maybe quite broad permissions. And if you could host all of that in a virtual cluster, you're kind of protecting the outer layer, but giving them, you're not slowing down developers. And I guess that's almost a superpower to a point, and that the development team can now just work with whatever permissions they need without having to constantly come back to the operations team or the maintenance teams, the SRE teams, and going, hey, I need this new permission, or I need this. So.
Yeah, and I think that I think CI/CD is really tricky, right? Because if you're in a situation where you run a lot of tests and they take a while, there's always that trade-off, where you're trying to reduce how long the tests take, and you're trying to do everything that you can to sort of, shrink that amount of time before the developers get feedback. And, you're often, making trade-offs like, do I want to have a VM with a cluster already baked into it, or do I want to provision a cluster every time? And there are pluses and minuses to both of those things. The more that you bake in, the more that you have to deal with, like, recreating images or updating them somehow. And, if you provision stuff on the fly, then you've got to wait for all of that to happen, And so the situation that I think we've gotten into with the Kubernetes multi-tenancy problems is this cluster sprawl, where people feel like it's easier to just make a new cluster for everything than to think about dealing with multi-tenancy, and that's really, I think, a lot of what we're trying to address with this tool.
Wow, big mission. I'm looking forward to checking it out. But it sounds amazing, and I think there's just, you're right, there are so many different use cases. I like the CI/CD one. That one hadn't really occurred to me until you mentioned it. And then the minute you said it, it was like a little light switch. I was like, oh yeah, he's totally right. Like, it's a great use case. Is vCluster something?
We have actually a...
Sorry, I need to go, Rich.
Oh, I was just going to say, David, we've got a really big announcement today. Do you want to talk about that, Lukas?
Oh yeah, sure. Yeah, we're actually breaking the news as of right now in this call. So vCluster is now a certified Kubernetes distribution. So one of the, I think there's like 80 distributions out there, and we worked pretty hard on the past couple of weeks to pass all the conformance tests that the CNCF put out there for certified distributions. And yeah, pretty happy to report that they merged our pull request now. The logo does not show up on the website yet. That's to come hopefully in the next couple of days. So this is really like breaking news, but super happy to report that.
Yeah, that is a big deal. Congratulations. That's awesome. It's a fully conformant Kubernetes cluster running inside of a namespace on a Kubernetes cluster.
Yeah, we have to give a shout out to our CTO and co-founder Fabian Cram too, who has built a lot of this. He's just a machine. He just codes like crazy and builds such cool things.
Yeah, he's probably on it right
now. So I'm assuming there was maybe a couple of things you had to fix to pass the conformance test. Are any of those quite funny that you want to share with us? Anything that snuck through?
Yeah, I think the most tricky part was actually getting things done in terms of nodes, because Kubernetes has certain restrictions regarding, if you're thinking about a virtual cluster that runs inside a namespace, what happens to the nodes, right? Do you see all the nodes in your underlying cluster? Do you only see the nodes that you actually have workloads running on? Do you only see like nodes with a certain node selector and all these kind of things? So yeah, we had to add a couple of flags to essentially enable certain configurations to sync all nodes from the underlying cluster and things like that, because that made it much easier to run these tests that the conformance tests essentially require.
Awesome. Yeah, I hadn't really thought about that. What I would expect get nodes to return inside of a vCluster. I guess based on what you just said, it's all configurable then. So me as the person deploying vCluster, I decide what should come back there, right?
Yeah, exactly. I mean, we're trying to add as many config options as possible. vCluster is actually pretty much, I mean, you can either just deploy a stateful set, right, and a service, and that's a vCluster. You can basically run kubectl apply. So it's basically just what arguments you provide for the entry point of the two containers, right? We have a K3s container, and then we have the syncer container that actually does the synchronization between what's inside the virtual cluster and what's outside in the real cluster. And typically you deploy it via Helm, and we try to expose as much as possible. So, there are so many different use cases for virtual clusters. We talked to one company that started using our product to essentially, kind of simulate clusters and simulate, what happens. So they wanted to test like what happens if we run like 500 daemon sets, right? And, or across 500 nodes. And then the question comes up, hey, can we actually produce fake nodes with vCluster? So that's something we're currently looking into. And, there's so many use cases that people come up with. It's incredible.
Nice. And this is pretty new, in terms of the open source project. We just released it during KubeCon publicly, but this is technology that our users on our commercial product have been using for a while. So it's actually a lot more baked than you might think from, a brand new open source project.
All right. Well, my interest is certainly piqued. So why don't we get this deployed to my cluster? And feel free to share all of your experience and history of the project as we go. And I will do my best not to mess this up too much. So I have my screen here. This is the vCluster documentation. We're going to work through the getting started guide. And if nothing has broken in the last 10 minutes, we should have a cluster. We do. There we go. All right, step one. I'm assuming I just deploy vCluster. So do I need the CLI? Is that?
It's going to be much easier if you're using the CLI.
Well, I do like easy mode, so let's do that.
Yeah, and of course, this is a quick start, so it's not necessarily how you would, productionize this, I guess, but.
Oh, yeah, that's all right. Quick starts, they're more fun. Mm-hmm. Deploying stuff to production is too hard. I'll deal with that. Deal with that in the future. Okay, so we have the vCluster CLI, and then step 2 is that we want to create a vCluster. And it looks like you offer, let me zoom in on this a little bit, multiple approaches to do this. So it feels like, is the vCluster CLI just optional? I can do this through Kubernetes manifest, but like you said, the vCluster CLI is going to keep this really easy for me. Okay. C is nodding.
Yeah, exactly. I mean, you actually see the output in the CLI, and it essentially runs Helm under the hood. So if you already have Helm installed, you're going to see the command on there.
All right. So let's just copy this command. And this is vCluster create vCluster1. Okay, so this is just the name of my virtual cluster. And then this is the namespace to run it in?
Yep.
Okay, so do I need to create that namespace first, or is that created for me as part of the vCluster create?
You just need to do the command in the quick start.
All right. Let's see what happens. Dun, dun, dun. It worked? Is that it?
That's it.
Yeah.
We have a vCluster running now, hopefully.
So, and again, when we were talking about, the speed difference, within a workflow like a CI/CD workflow or something like that, this is literally just, deploying a couple containers with a Helm chart.
All right. I mean, it's not supposed to be this easy. I'm just going to throw that out here. Like,
we can screw it up. Is this clustered? I thought that this is Rawkode Live. Am I on the wrong show?
Yeah, that's right. You're right. Although I'm already thinking that vCluster can provide some pretty interesting clustered scenarios. So maybe another day. All right, let's see what it's done to our cluster then. I know I'm going off script. I don't know if the Getting Started guide is going to actually guide me through this, but the questions in my head are, what have you done to my cluster? So I can see that namespace was created. I want to see if we have anything running inside of our namespace. And it looks like we got a core DNS running and a Rawkode Live 0. So that's the stateful set that Lukas mentioned earlier. Are those the only two modifications to my cluster, or is there something else?
You should see a service as well in your cluster.
A service.
Yep, I mean, I guess two services, because it's a stateful set, you're also going to need the headless service, but yeah. And then actually what you see in terms of DNS here, that has already been deployed inside your vCluster itself. So that's kind of how you see how things are mapped to the underlying cluster. So everything you're creating inside the vCluster, and the first thing a vCluster does, it deploys DNS to itself, essentially. Is all the pods that are being created and some of the services that are being created inside your vCluster will be synchronized down to your host namespace, and they will be rewritten. So you kind of see the kube systems or the X kube system X here inside the name that actually shows you the namespace inside your vCluster, because we're mapping your 500 namespaces inside your vCluster to a single namespace inside your underlying cluster, essentially.
All right. I want to digest this a little bit. I want to make sure I understand what's happening here. So I think the first thing I want to make clear to people is that if I run pods inside a virtual cluster, those are still just pods running on my host cluster. That's correct, right?
Yeah. So,
exactly. The vCluster has no scheduler.
Yeah. So what it does is there's a syncer that syncs those pods to the host cluster, and so as we get into it more, and you deploy something, if you have something you can run inside there, we can look at how that looks.
Okay, I want to clarify a few more things before my that mind blowing emoji. I feel like my head's going to be doing that in a minute. So what we have in our Rawkode Live namespace here, that I'm assuming that Rawkode Live stateful set 0 pod, is that an API server?
Yes, I mean, there's the regular K3s API server, and typically it has a SQLite database, but you could also, we expose all the K3s flags essentially, right? So you could essentially use etcd as a backend, right? Or MySQL as a backend rather than SQLite. But SQLite is the easiest and, quickest option for, quick starts. So that's why that's the default option for us. And then you also have a controller manager. It's all packaged in K3s essentially, right? That's kind of the power of K3s, packaging everything in that single binary. And then the only thing that's missing in terms of Kubernetes control plane is the scheduler, right? Because we don't have any separate nodes, and we actually want to, deploy things in our underlying cluster. And instead of the scheduler, we're using a syncer. And that syncer monitors, what's happening inside the virtual cluster, and then synchronizes resources down to the host cluster to the same namespace, It rewrites certain things, as you can see with these pod names, etc., to prevent naming conflicts because we're mapping to a single namespace. And on top of that, it synchronizes the status of these objects back into the vCluster. So that if you're inside the vCluster, you see, image pullback off and all these kind of statuses that your pods can have. And it looks like a regular cluster.
I was very mind blown emoji when I started playing with this too. So I definitely get the feeling. It's super fun.
I think I've got a handle on it now. So I'm going to walk through the life of a pod on a vCluster, and if I get anything wrong, please feel free to correct me. But you've got this K3s API server running on the host cluster. I can add whatever configurations to that I want through validating webhook configurations, mutating webhook configurations. I can run my own operators and controllers in it. I can apply all my resources to it, and all of that just works. And then the magic sauce is the syncer then. So it's just sitting looking at the SQLite kind database in the K3s, and then propagating enough of that back to the host cluster to be able for the workloads to start running, but then you also pull back through the status updates from the host cluster. Does that ever lead to contention between what the host cluster wants to do versus what the K3s server wants to do? Or does it just work very nicely and harmoniously?
Yeah, it works pretty nicely because the responsibilities are pretty isolated. Again, it's basically just a different kind of scheduler, right? A scheduler that instead of actually scheduling workloads is basically just copying workloads to be handled by another scheduler. That's what it's doing.
I guess what I'm thinking is if I have a mutating webhook configuration in the host cluster, which is adding a set of labels, and then the host, for whatever reason, has validating webhook, which doesn't allow those labels, you then have to kind of navigate a little bit of turbulence. But I think that is so contrived that it probably just wouldn't happen. But that's
actually a super exciting scenario because that's kind of the world where we're coming from. We created vCluster. Again, as Rich mentioned, it was part of our commercial product, right? Our commercial product is essentially provisioning development environments in form of namespaces for engineering teams in a kind of self-service fashion. So typically, you have all these constraints that we just mentioned, right? You have network policies, you have validating, mutating webhooks, etc. Whatever your admin team defines to, secure the operations of that shared multi-tenant cluster that a lot of the teams are, creating namespaces in now. And then when you do that, you're restricting your users. And that's essentially where we were thinking about, hey, what if users need to do things across namespaces, right? Now the network policy needs to be adjusted for that particular use case. Are there things that we can do to make those things easier? How can they deploy their own CRDs, have their own controllers and work on those kind of more advanced objects? How can they mess around with RBAC, just because that should be part of their, Helm chart that they want to, check into Git later on or something like that. And that's essentially, the answer to those questions was vCluster, because you just need access to a namespace, then you deploy a vCluster, and now you're admin of that vCluster. And yes, you can add a lot of things to that cluster. You can add, validating mutated mission control, etc. But you're still going to be also validated and mutated at the lower level, right? Mm-hmm. That's actually the beauty of this, because your pod gets checked twice, right? Because the syncer connects to your underlying cluster and basically does a kubectl request, right? And if that fails, you're going to see that in the status of the virtual cluster as well. So it's transparent to the user, right? But yeah, there are more layers now that you can add these constraints essentially.
Yeah, I guess that's almost a double-edged sword as well. I can imagine a situation where people may think, oh, I'll use the virtual cluster so I can run containers as root, but the host cluster may have a policy that doesn't allow that. So you're not violating the host policy, it's still going to block it, but at least they can try in the virtual cluster, which is quite interesting. I like that. Okay.
Yeah, so, I think as a user... as a user, you would want to get educated about what those policies are anyway, right?
Oh, yeah.
Because eventually the things that you're playing around with are going to hopefully, land in production, and you're going to be under those same kind of constraints.
Okay. I'm curious, and instead of asking a question, let's do something with our vCluster and see what happens. I'm assuming, and I know I should probably go back to the docs. In fact, I will go back to the docs. Unless it doesn't do what I want to do next, in which case I'll go off script again. But so we can do a connect. It is going to do. Right. This is what I was curious about. When I connect to the virtual cluster and I create a namespace, what happens on the host cluster? I'm assuming you create a namespace there and there's a mapping between the two, but maybe I'm wrong. So let's do this connect command first. And this is where I'm going to regret changing the name of the cluster because now I have to change all of my commands. That's a rookie error, but and I'm not going to press return on that because this creates a kubeconfig.yaml, and I may have one of those. Do I?
It creates it in your local directory, though.
Yeah, this is a cluster API cluster, and I have a KubeCon. Oh, but not a YAML. Okay, we should be okay. I was worried I was going to blow away my kubeconfig, and that would have been the end of our session, but we should be all right. Okay, what do we got? We got a config written to .yaml, so we're safe. We can access the cluster by using the kubeconfig, and it has started a port forward. So do I need to leave that port forward running to interact with the cluster? Yeah, okay.
Yeah,
Yes.
You're going to want to do that.
Oh, come on, computer. There we go. So kubeconfig. Look at that. I mean, that's a bit weird for a get pods all, but I understand why. I would be very worried if this was cluster and that's all I could see, but this is what we expect, so I'm happy with that. So I'm going to create namespace. I'm going to try and trip it up just because I like to do that. So all right, so that did work. Let's run get namespaces. And I'm going to do that again on...
Yeah.
Okay, so interesting. It's not what I expected, so maybe we could dive into that a little bit. When I create a namespace on the virtual cluster, you either don't create it on a host cluster until I add some workloads to it, or you just don't create it at all. You want to dive into that a wee bit?
Yeah, we don't create it at all, essentially. So what we do is we map your X namespaces inside the vCluster to the single namespace where the vCluster stateful set is deployed to. So no matter how many namespaces you create, all the pods that you create in these namespaces end up in the same namespace in the underlying host cluster.
Of course, because you can use vCluster when you only have access to a namespace. I didn't think of that. You do confine everything to that boundary, which makes a lot of sense.
Exactly. When you create a namespace, that's a request to the K3s API server, and it's stored in your SQLite or etcd or MySQL or whatever is the backend for your K3s API server, and that's it. Nothing else happens.
Were you going to say something?
And you can literally delete that namespace, and everything goes away.
All right. So we also got a question from Rio in the chat, which I think we've just answered, but I'll throw it up anyway, and you can feel free to add any extra flavor to that as you want. But Rio says, so a user who deploys vCluster only needs to have admin role bindings to a single namespace.
That is correct. Yeah, that's essentially the core story for vCluster. As long as you can create, a stateful set and a service inside a namespace, you can, and I mean, you have to have the privilege to also do port forwarding if you want to connect to the vCluster, obviously. But other than that, yeah, you don't need any privileges. So if you have admin role binding in that particular namespace, then you can deploy vCluster.
All right. And Noel has a comment that I'll pop up, but I think we've kind of just answered that as well. Noel is saying that the syncer just manages everything from the vCluster namespace back to the hosts.
Do you want to talk, Lucas, about which objects get synced?
Yeah, so there's essentially, we kind of differentiate a little bit between, and we have a separate docs page about that as well, regarding high level and low level resources in Kubernetes. So we see the lower level resources, like pods and service, different from higher abstracted resources like, deployments or stateful sets or even CRDs, right? And what we need to sync is essentially pods, services, and everything that pods need to run. So let's say you mount a secret, right? Then we may need to sync that secret, right? Otherwise we can't mount it. Or if you mount a config map, it's the same scenario. But all the other 500 secrets and config maps you may have in your vCluster don't need to be synchronized. So we're pretty selective in what needs to be synchronized. But obviously we need to synchronize everything that's required to actually start a certain pod. And we need to synchronize services just so that we can make networking between your pods inside the vCluster work, and that they also, can communicate, via services rather than just on an IP-based level between each other.
Okay, that makes a lot of sense. I think it's really smart, that kind of selective sync based on whether something is actually being consumed or used is really clever. Is there things that cause problems here? I'm thinking storage and CSI plugins. Like, I guess, do I just have access to whatever the host has, or is there something a bit different there?
Yeah, that's typically, you can have, so essentially the vCluster can have a subset of things that are available in your host cluster. That depends on the configuration, right? So essentially, think about it like a storage class, right? If you were to use a storage class and you want to create a persistent volume claim, for example, in your vCluster, you got to have that storage class, otherwise you can't use it, right? Otherwise it simply doesn't work in Kubernetes. And that storage class, obviously needs to be from your underlying host cluster, because that's where that pod actually got started. So you can't just come up with, other resources not available in your host cluster regarding, actual pod workloads and volumes, etc.
All right, it makes a lot of sense. We got a comment from Rio, who's obviously very excited. There goes their custom Docker and Kind CI setup. So we've got a vCluster convert already, and we're only half an hour in. It's awesome.
I do want to say that we love Kind. Like, it's an amazing project, and it's done so much for the community. I definitely think their vCluster isn't necessarily the right tool for every situation, but I do really like it for that CI use case for sure.
Nice. We got a security question from Noel in the chat, who is asking whether the K3s API server runs as a non-root, and they're wondering about potential, user breaking out of the virtual cluster into the host cluster, and whether that should be a concern.
That's actually a pretty good question. I'd have to look pretty deep in the code myself to find out what the answer to that is. I assume if you can run it without root, it would be possible with vCluster as well. I don't know if it's the default for us or not.
I guess they're still contained with the namespace that vCluster was deployed to as well. So if you got your RBAC policies correct there, it's pretty strict, I would imagine.
I actually
I assume that
I have some
K3s is just a single binary as well. So even if you were to break out of the actual process there or something, you'd end up in a probably like distroless container. I assume that's how K3s is packaged, but I'd have to look in how they're packaging things, because we're basically just using the image off of Docker Hub. So I don't know if it runs with the root user or what's inside of there.
Yeah, I don't know the answer to that question either, but I do have some friends that are pretty security minded that were playing around with it, and the thing that they emphasized is the importance of doing admission control, on the host cluster.
Yeah, that makes a lot of sense too, definitely. Okay, I detoured us a little bit there, so let's jump back to our Getting Started guides. So we did the namespace, we checked that out, we created a namespace. Now we're going to deploy our first workload to our virtual cluster. So I'll need to change this a little bit. Config.yaml. Oh, it's the namespace. Oh yeah, because I decided to trick it. See, and then the image. Okay. Awesome. So we should be able to run get pods, all namespaces. And we have an Nginx pod being spun up in a Rawkode Live namespace inside a Rawkode Live virtual cluster inside a Rawkode Live namespace. Easy.
It's a lot of Rawkode Live going on here.
Yeah, I'm starting to.
Rawkode Live Inception.
There's a lot of Inception vibes going on here, that's for sure. So let's run. I just like seeing what happens on my host. I'm assuming based on all the conversation we've had now is what I expect to see is in my Rawkode Live host namespace, there to be a pod that's potentially called Rawkode Live, Rawkode Live, Rawkode Live. Because it would be namespace, vcluster name, and pod. That sound right?
Yeah, pretty much. That should be what it's looking like, yeah.
Oh, we don't want to do all namespaces here. We want to see here. Ah, no, okay. So I never called my Nginx deployment Rawkode Live. I should have. I missed the trick. But we got Rawkode Live, Rawkode Live. There you go. That was cool. I like that. And yeah, so the secret sauce is the syncer, right? The syncer is the one that does all of the magic here. It feels to me like there's so many, there could be more applications to this syncer than maybe just virtual clusters. Like I'm thinking maybe cluster federation or disaster recovery and being able to copy stuff over. It feels like that could be applied in actually maybe a couple of different ways.
Yeah, it's actually pretty crazy. Again, I mean, it's even crazier since we open sourced vCluster, but even before as part of the commercial product, it's crazy what people, come up with in terms of ideas. And so far, we started with essentially virtual clusters as a way to, give extra privileges to users that are confined to a namespace typically. But then the next question is the one that you're asking. That a couple of folks have asked us as well is, can't we back a vCluster by different physical clusters, right? It's a super interesting thought because the syncer, I mean, basically just wants a kubectl apply command, right? Technically, I mean, obviously it's using client Go, etc. But that's what happens under the hood. And it could technically, route different pods to different clusters in a way, or, sync them to like 5 clusters in parallel. There are essentially unlimited possibilities here, and it's super exciting to explore those use cases. But so far, that's not a main priority.
Awesome. Okay, so we can clean up our vCluster now using vCluster delete, or is there a few things that we should kick the tires on before we do that? What else does the vCluster CLI do?
It doesn't do a whole lot more. I mean, you can upgrade the vCluster CLI for itself, right? And other than that, it's really just create, connect, delete.
I guess that's all you needed to do. So nice. All right. What should we do with our virtual cluster? Do you have any cool things that you normally deploy to this?
Yeah, I think one thing to check out is essentially what happens with the nodes. You do have a multi-node cluster, right?
Yeah, we've got a control plane node and 2 workers.
Yeah.
All right, we could check out, what happened with our pod. Do we see nodes inside the vCluster? That is typically what a lot of users are interested in, because that's a non-obvious question, right? What happens there?
Yeah, we actually we touched on that, and then I forgot. Oh no, that's namespaces. Nodes. All right, so I see both the workers and the control plane is removed. I guess this is the default configuration for how to expose the nodes.
I think the default right now is, we actually changed the default recently, but I think the default as of today is that we show you the nodes that are actually, that you have workloads running on. So your pods get scheduled by the underlying cluster. And I assume that you have two pods, at least, or like one pod on each one of these nodes, but not one on the other one, probably because you have some kind of taint there that doesn't allow pods to be scheduled.
Yeah, we got our core DNS on one of the nodes. We got Nginx on the other. And I actually removed the taint from the control plane node, so we had 3 to play with. So I guess that means that I could do an edit deployment Nginx. What did we call that? Or demo Nginx. Oh, there's a namespace involved too. Oh, did I change it again? I'm going to have a word with myself. All right. Okay.
You need to learn the power of copying and pasting, David.
I know. I'm just going to scale it up. See if we can get that onto the control plane node, run the get nodes. I like that it kind of tries to work out which nodes it has to expose. I can imagine in a scenario where I've got my host clusters running on 20, 30, 100 nodes, whatever that is, and people have access to vClusters. You're really restricting the scope to what they need to see, or they have the ability to see, rather than just giving them a map of the world and going, here's all the things that we've got available to you.
Yeah, it's actually quite interesting. I mean, we already talked about, mutating admission control earlier inside the host cluster. And what you can essentially do inside the host cluster, you can, enforce certain nodes for certain users with mutating admission control, essentially just on a pod level. You don't need to worry about a whole lot of other resources. You essentially just worry about the pods. And then, you essentially, rewrite these pods that the sync synchronizes down. And that way you can essentially restrict nodes as well for, although you don't add anything to the vCluster, just by adding admission control to your underlying cluster.
Okay, I like this. So what you were saying, sorry, on you go, Rich.
Oh, I was just going to say, I'm with Noel. Noel mentioned in the chat that he's adding it to the log list of tools to check out. I know that feel.
Yeah, the cloud native landscape just seems to continue to grow at an absolute wild rate. There's just so many cool technologies coming out, solving a whole array of really cool problems. It's phenomenal to watch.
Yeah, one of the reasons that I was really interested in coming to Loft is that, like, I just know that people have felt a lot of pain, over multi-tenancy and self-service, and that these things are really big issues for people's productivity, for the engineers and for the platform teams and people who are supporting them too, and you used the word clever earlier to describe something about the design, and I think the tools are smart. I think vCluster is a smart tool that solves real problems.
Definitely. So something's crossed my mind now, and I'm going to throw it out there. I just ran get nodes on the host, and we've seen the control plane, the 2 workers. Apparently my ability to remove a taint is, well, as crap as everything else I've done so far, but the age on my host nodes is 70 minutes and 50 minutes. The age on the second worker node in the vCluster is probably from when we deployed Nginx. So that's something that the KCS cluster is registering. It's actually registering a node with KCS when something gets scheduled there.
Yeah, that's exactly what happens. You also see that the version shows K3s as well, right?
Well, that was my next question. Like, can I deploy 121 as a vCluster? Can I drop down to 116? Like, can I get really weird testing situations running across multiple Kubernetes versions, regardless of what my host cluster is?
Yes, you can. I think the only limitation that you have is the pod spec, right? Because we're synchronizing your pods. So if there is a feature, if you're using a vCluster with a higher version than your host cluster, and you're using a pod spec feature that is not available in your underlying cluster, and that is one of the fields that we're syncing, so an essential field, right? Then that may lead to a problem. But then you're just transparently going to see it in that in the status, right? So you can get around these things, and typically, pod and service, which are the core things that we're synchronizing, they're rather stable. The Kubernetes API, not a whole lot of things are changing,
Yeah.
Whereas things like, ingress, or obviously, CRDs change even more frequently. That's typically the things that would break a lot more. But yeah, people are doing that. People run entirely different K3s versions on top of, other Kubernetes versions. And that's actually one part where it's super interesting for CI/CD as well, right? If you want to test like 20 versions of Kubernetes at once, right? You just spin up 20 vClusters real quick.
Yeah, one of the use cases we didn't talk about is testing upgrades.
Yeah. Yeah, you could actually do that in a pretty safe manner, I guess, by rolling things out to a vCluster first, seeing what happens, and then going, all right, it looks good, or oh crap, things went wrong. And then, yeah, you got this nice, safe and secure way of handling that. That's a pretty cool use case as well.
Yeah, and I mean, again, if like Lukas was saying, if you're doing CI/CD against a specific version of Kubernetes, you could do a scenario where you run the tests against both for a little bit, and make sure that the newer one is working as well.
Okay, so I'm curious about this version thing there. Is this the flag I need? I just specify the K3s image, and that's the version of Kubernetes I get in my virtual cluster?
Yeah, that's pretty much what works, yeah. You can also, if you're looking at the documentation and you see, the kubectl deployment option and the Helm deployment option, how these things actually get passed down. The CLI is basically just, running Helm install or Helm upgrade under the hood, essentially, and passing those things to that Helm chart. And that Helm chart is basically just adding that there's an extra arcs that you can pass, and they essentially get concatenated, to the regular arcs that we pass in K3s.
We don't need docs. I've got YouTube. I'm so curious now about this version thing that I need to try it. So, how old can I get? Let's see. No, K3s isn't that old. There we go. Let's try this.
What's your host cluster?
120.4. So yeah, I think I'll create a 116 and a 121 just for no other real reason than I think it's cool that I can do that. Like, that is just very exciting to me, and I don't know why, but go. I'll grab the 121, which is, I think the latest is 121.2. Yeah, there we go. Too much fun. That's what I'm saying.
One thing I also want to mention is you always change the namespace here. It's also possible to have multiple vClusters in the same namespace. That's technically possible as well. Typically, we recommend, for easier visibility in what actually is happening under the hood, to isolate them to different namespaces. But it's certainly possible.
I'm just sitting here popping up Kubernetes clusters like nobody's business and having a rare time. So
it's also possible to run a vCluster inside of a vCluster, which I actually did a YouTube video where we do that on the Loft YouTube. It's pretty fun.
What? So you've got a V cluster running on a host cluster. You create a V cluster in a V cluster, and the sinker just goes to the sinker, and the sinker goes back to the host cluster. So it's just 2 layers of. How many have you tried? How deep have you went, Rich?
I've only done that second layer.
I mean, I'm going to have to try it. So, all right. So this is. I'm going to get so confused and forget where I am. But I'm going to. This is me on V cluster 1. And now I'm going to create another V cluster called vcluster 5. Okay. It looks like it may be working. Okay, let's see what happens when I do a list. So this is inside of vcluster 1, and we have access to vcluster 5. If anyone at home is actually managing to keep sense of this, you're much better than I am. I'm going to unset my kube config, which puts me back on the host. I don't want to be in the host. I want to be on my remote cluster. Okay, I may need 10 or 20 minutes to work this out. So a vCluster list
It took me a while to work it out when I made the video.
So this is really cool. I have 4 clusters on bare metal right now. Oh, I shouldn't do it all because there's too much running. Let's do this.
Oh man, we should have made a VM on the bare metal to run the vClusters inside.
The 116 failed, but we'll ignore that. We got our Nginx's. Oh. In fact, I think I just got all those images wrong. I think I've now got 5 broken clusters, don't I? Oh, I'm an idiot. See, when you know, you know. This is just a tag.
Oh yeah, you want to use what showed when we did the get nodes, right?
I guess it should be rancher / KTS and then the tag. Okay.
Yeah, don't worry about it. Just run it again. It'll essentially run Helm upgrade.
Oh, nice. Okay, so we can run.
The only thing to note is because they're stateful sets, the pods actually don't get recreated. You'll have to delete the pods, but then they get, the new pods that will be scheduled. They will essentially have the new image.
Okay, so let's see if we can upgrade and fix the broken image on Rawkode Live 2. And we'll try even get a 121 cluster out of this. Yeah, so there's a Helm upgrade. Which means I should be able to run this. And you said I might just have to...
Yeah, you see that there's still 3 minutes old, or... Oh no, that one actually got recreated. Oh, I think if the image is changing, yeah, then it restarts it.
Yeah, it's running. Okay. Let me recreate my 5 clusters again in under 1 minute. 116. Oh, that because okay, yeah, I did change the image for that. So let's do rancher KTS, and this can be cluster 3. And I'm so confused. Now I want to connect to vCluster and create another cluster for cluster inception. vCluster. Oh no, my connect's up here, right? Yeah, cool. And this one we'll do 5. And yeah, so we'll just do that. Okay, I have no idea how many V clusters I've got anymore, but we definitely have some virtual clusters. So we can do a V cluster list. We'll connect it to the current V cluster, and we can run get pods all. And this is a V cluster, so we should only see. Apparently, oh no, this will need me to delete the pod because. Juggling too many things, but we'll get there. This should just not be this much fun.
I mean, I have to say that's been my reaction the whole time since I started playing with this project. I just think it's super fun, and a lot of what we do, as ops people and platform engineers and product engineers isn't necessarily fun. So my theory is that you embrace the things you can do that are, right. So if you get to play with a tool that, is really fun, that you enjoy, run with that if you can.
Couldn't agree more. All right, let's confirm our versions work, and then I'll stop doing silly things, I promise. But we have connect here, and we're going to connect to vCluster 2, which I think is a 121 cluster. So I should hopefully still be on. There we go. We got a 121 cluster running on a 120 cluster. That's pretty sweet. That's awesome.
It is. I wanted to thank Noel too, who said in the chat that he enjoyed that video that I was talking about on YouTube. I appreciate that.
Nice, awesome. And Noel is now suggesting that on clustered, everyone's going to be getting a nested vCluster. Potentially, pretty nice way of doing it.
I'm not sure if that would be fair, but
all right. Yeah, this is really cool. That version thing was a nice little cherry on the top there as we went through this. I wasn't expecting really. I mean, now that I've done it, I'm like, well, yeah, of course we could do something like that. But it didn't occur to me. And now that I know, I can have multiple versions of Kubernetes API available. Even just building operators and being able to run end-to-end test against all of these versions and do that super quickly against that's really nice. I like that completely. Awesome.
There's one more topic that may be interesting, and that's actually networking. The reason, why networking for in-cluster stuff works out of the box is essentially because the pods are running actually on your host cluster, right? So they use your regular, network plugin that you're using for your host Kubernetes cluster. And then what we do essentially inside the vCluster is we just, because we're syncing the services, but we're also renaming them, again, to prevent naming conflicts. Because, again, we're mapping from 5 namespaces to a single host namespace, right? The only thing we need to do is adjust the cluster internal DNS and tell these pods to talk to the DNS server that is running inside our vCluster, which also creates a pod in the underlying cluster, so you can basically also connect to it via regular IP. Sounds a little tricky, but essentially, again, networking, so in-cluster networking, so connecting to any services inside your vCluster works. And you can also, immediately talk to other pods via IP. And the really interesting part is actually regarding ingresses. Because, frequent use case is that you don't want every one of if you're in that use case that we're originally coming from, right? You have like users in their isolated namespaces. Typically they share an ingress controller, right? Or they have like a couple of them available in the cluster. If you're using vCluster, you don't want everyone to deploy their own Nginx and have to, provision their own load balancer or something like that, right? It's a little bit more tricky. So by default, vClusters also synchronize ingresses. But that can also be, turned off and on, etc.
Okay. Yeah, that makes sense as well. Does that mean if say I bypass the DNS within the cluster, I just start using pod IP addresses, that networking is going to work, right?
No, that network works. So, your pod is actually, so if you're inside the pod, right, if you were to just run kubectl exec inside a pod that you deployed via the vCluster, then you're technically inside a pod of your host cluster, right? And if you were to ping another pod in your host cluster with that IP, that should work, unless your network policy is forbidding you to do that.
Some interesting use cases there. I'm thinking like as me as the operator of the host cluster, I can actually make some things available to vClusters using the host networking thing. Like I could say, here's a HTTP service that's going to give you access to secrets or metadata or something, and then they just know this magic IP address or whatever is going to work. I'm not sure what a real world use case is there yet, but there's something there.
No, it's funny that you're mentioning that's actually one of the most requested features for vClusters, because what you described right now is what we recommend as a workaround, right? So we have the common use case that you have like a very bulky application or kind of like a test system or something that people need to connect to, right? Just think of like you have as a cluster admin, you want to make a Kafka cluster available for your engineers, right? I think that is one of the use cases that one of our customers was outlining, and they don't want everybody to deploy their own Kafka cluster because they're pretty bulky, right? They tend to break, and it's very high maintenance, and they're already inherently multi-tenant, right? So they can essentially, with different credentials, manage different users. So why not run a central instance and make it available to your engineers, right? And then the question is, how does your pod that you created in your vCluster now connect to that service? Because that service of that Kafka cluster does not exist in your vCluster. There's essentially two answers to that. One is if you have a IP which is not supposed to change frequently, right? Because you created that service for the Kafka cluster, then you can directly, of course, communicate via IP. And the workaround would be to essentially just create that service inside the vCluster. So essentially run a kubectl apply to create that service, to kind of have like a fake service inside your vCluster. That is something that works right now, but we're thinking about other ways. What obviously operators want to enable for their engineers is a more automated approach to this, right? Where they don't need to play around with things like that. So we're currently thinking about ways to synchronize resources from the host cluster back into the vCluster, essentially, so that services start popping up that you have not created in the vCluster, but you want them, to be synchronized from the host cluster into the vCluster. That would be a use case for this.
Yeah, I was just thinking that, like, if I could label my Kafka service on a host cluster in some way that associates it with the vClusters, and then the syncer will create those services for me, that would be a pretty interesting setup as well.
Yeah. So this is open source. It's on GitHub, github.com/loft-sh/vcluster. And, we have been getting some issues from people. People are kicking the tires a little bit, and it's really exciting. You just can't predict what people are going to want to do, until you throw something out in the wild like this.
Nice. All right. Let's clean this up. I'm assuming this is going to be really, really simple. And I have no idea what kubeconfig I'm on anymore, so let's work that out. Okay, that's good. So let's go back to this one. vCluster, delete. Oh, no. Copy and paste, Dave. That's the future. Stop changing stuff.
Yeah, since everything is contained inside those namespaces, so the vCluster itself, right, the stateful set and the service, as well as the workloads that run inside the vCluster, it's actually really easy to purge a vCluster. You can just delete the namespace.
Yeah, so you could literally on your host namespace delete those namespaces.
Done. All gone. Yeah, that was much easier. I was going to go vCluster delete and work my way through them all, but yeah, I can just remove that whole namespace. And that's the great thing about vCluster is I only need a namespace and I can clean it up with just a namespace. That's very cool. All right. Is there anything else? I know I haven't really stuck to the documentation too much, but is there anything else that we want to go through before we finish up for today?
Maybe just a quick shout out to what Fabian has been working, our CTO at Loft Labs. He's been spending a lot of time on this. You see that their operator guide, monitoring and metrics. He's been spending a lot of time on actually making things like kubectl top work. So essentially, having the capability to deploy a metric server inside your vCluster, and then hook up monitoring via Prometheus and stuff like that. So that's really moving more from, the dev stage towards staging environments, production setups, because they're very interesting use cases in that space as well. And we'd like to explore them further. But obviously we need to provide some more, tooling for operators to gain confidence that they can actually, run that, in staging and production scenarios. Because without monitoring and metrics and things like that, that would not be possible or not recommended.
Very cool. Yeah, I hadn't even considered those kind of day 1, day 2 things, but it's nice that those are being worked on.
Yeah, the tool is very rapidly changing, and Fabian's amazing, like we mentioned. Just want to thank to the folks who have been like kicking the tires on this thing and giving us feedback. It's so helpful. If folks watching the stream, play around with vCluster, we'd love to hear about what you do.
Nice. All right. Well, that was a whole lot of fun. I'm still a little bit shocked at the simplicity and how easy it was to really get everything started. You said at the start, using the vCluster CLI is just going to make things a lot easier. Yeah, it was easy, really, really easy. And the speed at which you can spin up and shut down those virtual clusters is a sight to behold. So thank you both for joining me and guiding us to this session. That was a lot of fun. I really enjoyed that.
Thank you, David.
Do you have any final words or anything you would like to share with the audience before we say goodbye?
I just reiterate what I said. If you kick the tires, please do let us know. I'm at Rich Burroughs on Twitter. At me. I'd love to hear about what you do with vCluster.
Awesome. And definitely check out the KubeCon podcast. Lots of fun there. David. All right. I will put links to all of this in the show notes. Feel free to play with vCluster, reach out to Rich if you have some fun, let him know if anything breaks. I'm sure they'll be very happy to help you. Although based on the things we were doing today, it's probably going to take quite a lot to break a vCluster. But like I said, I had a lot of fun. Thank you again for joining me, and I hope you both have a wonderful day. Thanks again.
You too.
Thank you.